Welcome to this session on automatic resource management. My name is Venkat Subramaniam. We're going to talk about this feature in Java 7 called automatic resource management, and we'll talk about the benefits of this and also some of the limitations and then where we can go from here. Well, when we deal with programs, we often deal with external resources. In other presentations, I talked about some of the challenges to rely upon automatic garbage collection to clean up external resources. So the responsibility is on our shoulders to make sure we clean up resources properly. Let's consider an example. Let's say for a minute we have a class called resource which is going to be dealing with some external resource. And we'll just keep this example trivial and simple so we can focus on the real problem here. So here is the constructor for the resource, and within the constructor I'm going to simply output creating so we can see that this object is being created. I'm going to go ahead and create a bunch of methods over here. Let's go ahead and say in this case I'm going to create a method, let's say some function fn1, and within this function I'll simply output fn1 called so we can see that we are using some kind of a method on this. And then we will also implement one more method over here which is function2, and the idea really is that this particular resource is using something external which is pretty heavyweight and we got to properly clean it up. So we're going to write a method called close over here, and then within this close method we will simply call it as cleanup. So here is where we are cleaning up, and that's when we get rid of the resource that we no longer want. So that's the essence of the code we're going to start with, a little example to play with, and then see where it takes us. So let's go ahead and create an object of resource and play with it. Now I'm going to say new resource over here, and in this case I'm going to assign it to a resource variable, resource dot, let's say the function 1, and I'm going to also call the resource dot function 2 over here to call those two functions. Now if I had written a finalize method, I would be eager to see if that gets called, and we know already from other presentations and other details we know before that finalize is not going to get called. So in this case we want to make sure the cleanup happens properly. So a way to solve that problem would be to say resource over here and then call the close method. Now in this case obviously the close method is being called, and if we had written a code to clean up properly that would happen because it did call the cleaning up and display it. Unfortunately, we have to handle with exceptions, so we have to really put a try and finally block around here, and then within the finally block is when we have to call the close method itself. And like we discussed in another presentation, this can be problematic as well. And the reason this is problematic is this is a lot of ceremony in code. We have to remember to write this, and this is a lot of noise in the code as well. Well, thankfully to address these problems, Java 7 has a feature called ARM, or Automatic Resource Management. So what is Automatic Resource Management? The problem really in Java is while garbage collection is automatic, it is not instantaneous. While garbage collection really focuses on memory related issues within the JVM, it doesn't care about external memory and external resources. So ARM is an approach to really deal with external resources. ARM is not new at all. In fact, C# has had this feature from almost day one. Now, if you are programming in C# for a minute, let's think about C#. Those of you who are familiar with C# know this already. You would be using something called using, and then you would specify the resource you are interested in using, so resource, and then within this block of code, you would be using the resource. In C#, the minute you leave the using block, this resource will be cleaned up automatically for you using the iDisposable interface's dispose method. Well, Java 7 really is trying to provide something very similar to using in C#, and that's what ARM really is. So automatic resource management is a way for us to very clearly indicate that our intention is to clean up this resource when we are done and provide a standard way to clean up those resources itself. Let's take a look at an example of how we would be able to use ARM, and then we will see how it eliminates some of the noise in the code we just saw. So For this to be useful, we have to use an interface called auto-closable. Now, so we're going to go ahead and say implements, and in this case, we're going to say auto-closable. And auto-closable is an interface with just one method, which is the close method, one abstract method, which is the close method. So if you go to the auto-closable interface, you would notice that in this case, it contains just the close method, which potentially could throw exception. Now in Java 7, a resource that implements auto-closable is required to close its resources, and that rule has been a little bit made more flexible in Java 8, that it may close the resource, but there are other things it could potentially defer to. So the idea really is that by implementing auto-closable, we are required to implement a close method. So if I don't have the close method right now, I'll get an error saying I'm not implementing the auto-closable. So it's quite incidental that I call this the close method, but had I called this the dispose method, I would have to rename that method to close or write another close method at this point. So that's basically the auto-closable interface. Now that we have written an auto-closable over here, we can make use of auto-closable and in turn make use of the ARM, or automatic resource management. Now what does ARM do for us? It really makes it more declarative in code to say what our intention is, and it reduces the noise in the code. So now we can remove the finally block entirely, and then we can go up over here and then move this resource creation right inside of this try, as if it's a parameter being passed in to the try block itself. Well, it's really not, try is not a function, but it gives us an illusion of that. So in this case, we are calling the try over here, and we are creating a resource in the try. And in other words, try will manage the resource we create under its umbrella. And then when we leave the block of code right here on line 15, the resource will be cleaned up properly. So if we run this little example now, we notice that the resource was created right here when we called it. We called the function f1 right here, as you can see. Then we called function f2, fn2 right here, as you can see. And then when we left the block of code right here, the cleanup happened automatically for us. So this is what ARM provides for us, in that if we use ARM, then the object that gets created right here would then get released right at the very end of this. Now, what if I want to use multiple resources in my code? So for example, let's say I want to create another class, resource 2, or maybe just another object of the same resource. Both of them are fine. It really doesn't matter. So we could try to put something along like this. We could say try over here, and we could say resource 2 equals new resource. So we created yet another object of this resource. And then within this code right here, we could go ahead and use not only resource 1, we could also use resource 2 as well and call the function on it. So when I run this code now, we can see that cleanup happened on both the objects in this case, because we have created 2 resources and we have used them. Now, while this is working, we can see that this is a little bit more verbose and noisy as well. Is it possible to combine the resource creation into one? So let's get back to the code we had a minute ago. So we have just this one resource we were dealing with in here. And you can also see that by having 2 of them, we increase the levels of nesting also. And that really makes the code a lot more noisy as well. Well, rather than doing that, we're going to come back over here and say resource equals new resource, and then we're going to specify over here resource, and then specify a resource 2 over here equals new resource, and create a second resource object. Now we can come back here and say resource 2 dot, and then we can call the function on it, and then let's go ahead and run this little code and see what the output is, and we can see that it cleaned up both the resources as well. So we can combine multiple resources to be created here also, and then as a result we could be in one level of nesting. And then when we are done with this, it'll make sure it calls the objects in the proper order to clean them up. Now you may be curious what's really happening when you write this code. So in order to understand that, let's go ahead and take a look at the little bytecode being generated here so we can appreciate the effort that ARM is putting for us in this particular case. So let's go ahead and remove the extra resource we created, just have this alone for a minute, and then we'll take a look at how this actually ends up looking under the code. So let's go to the terminal to take a look at it, and I have this code sitting here in sample code, and I want to go ahead and take a look at the bytecode. So I'll get down to where the compiled class is located. Java P-C is an alias I've created for Java P on my machine, and I'm looking at sample class over here. And if we look at this at the bytecode level, what we would notice in here is in the main code, which is where we have this the ARM being called, we can see that in this case it is calling those methods for us using the close. Right here is the close call being done, but we would notice that this is actually being done within the finally block itself if we take a close look at it. Notice that I only called the try block once, but you can see that it calls close in two different places. You may wonder what's going on here. Why is this being called in two different places? Because the code is trying to take care of exception situations and is taking care of handling those situations as well. In fact, it is a little bit more cautious in here, ensuring that the code is being run and close is being called, but in case there was exceptions, it is able to handle those exceptions situation by making sure the close gets called in there as well. So you can read this and see how the code we just wrote translates to what code at the bytecode level for it to handle properly. So this seems like a nice idea. What are some of the benefits of this? The benefit is, first off the bat, it is less noisy. The intention is clear. We are indicating that when we implement autoclosable, we are saying, hey, we got external resources we need to be mindful of, and we got to close them properly. So we are indicating those details pretty fairly well here, as you can see. So it seems like a great idea. Are there problems in using this? Well, the problem with ARM is that even though this seemed to have worked really nicely for us, what's going to happen if a programmer is a little bit forgetful, like I usually am? So I come along and I call the resource directly, and I forgot to put the try block. And sure, it's nice that I don't have to put the finally block, but I may forget to put the try block in the first place. So if I go back and run this little code right now and try to exercise this, you can see we are back to square one. We have really created the resource, but we haven't closed the resource itself. But this should be no surprise to us, because we should never trust a feature with the word management in its name after all, isn't it? Well, the problem really is that the ARM feature really is good, but it doesn't force the programmer to do the right thing. It still requires us to remember to do this. And that, while that's effective when we remember it, bugs creep in because often we don't. And that would be a nice, if there's a way to really make sure the programmer cannot forget this, that will be really nice. And thankfully there is a way to do that, and that is a use of the execute around method pattern. So I'm going to talk about execute around method pattern in another presentation, but this kind of nicely leads up to the problem, and now we can see a solution that's available in Java 8 and other languages as well that support Lambda expressions. We'll take a look at execute around method pattern in another presentation, but you can see the power and limitations of these approaches right here.